Hello, welcome to Prajim Technologies. I'm Venkat. This is part 30 of SQL Server. In this session, we'll learn about user-defined functions and their types, creating and calling a scalar user-defined function, places where we can use these, and finally how to alter and drop a user-defined function. From parts 22 to 29, we have learned how to use many of the built-in system functions that are available in SQL Server. In this session, we'll turn our attention to creating user-defined functions. User-defined functions are also called as UDFs. In SQL Server, there are three types of user-defined functions: scalar functions, inline table-valued functions, and multi-statement table-valued functions. We will be talking about inline and multi-statement table-valued functions in a later session. In this session, we'll concentrate on how to create scalar functions. Now, before looking at how to create a scalar function, let's look at how to use one of the existing system functions. Now, all of the system functions that we have worked from parts 22 to 29 are actually scalar inbuilt system functions. Okay, for example, we have the square function, so let's try to use that. And to use that, we use the select keyword and then square, the name of the function itself. And when I open this parenthesis, look at the IntelliSense of SQL Server Management Studio. It shows that this function is expecting a float parameter, and it returns a float data type, a float value. Okay, so if we give it a number, for example, let us say I pass in 3, so this function is going to square that function and return that the square back to us in the form of float. So if you understand, the functions have the capability of taking in parameters, do some processing, and return some values back. Okay, so when we execute this, we get 9. Now, is it mandatory for a function to have a parameter? No. We have also looked at many functions which doesn't take parameters at all. For example, if you take the getDate method, which returns the current system date time, it doesn't take any parameter. Look at this. This function doesn't expect any parameter. It returns the current date and time on that SQL Server instance. Okay, when we press F5, we get the current date and time. Okay, so a function can have parameters, that's optional, but a function should always return a value. Okay, so now let's go ahead and see how to create a user-defined scalar function. So what is a scalar function? A scalar function is a function that takes 0 or more parameters and returns a value. Okay, a function may or may not have parameters, but it should return a value. Okay, since a scalar function returns a single scalar value, it's called a scalar function. Okay, and to create a scalar function, we use the following syntax: create function, function name. Now, to create a stored procedure, we will use create procedure, procedure name. Similarly, to create a table, we use create table, table name. To create a function, create function, function name. And then we know that a function can have parameters. So within the parentheses, you specify the name of the parameter and its data type. Okay, you can have up to 1024 parameters. Okay, and then a function will also return a value. So to specify what is this function going to return, we use the returns keyword and then the data type. Okay, now if you look at the square function, it returns a float data type, whereas getDate function returns a date time data type. Now the function that we are going to write, whatever data type that it's going to return, you specify the data type after the returns keyword. Now remember, a function can return almost any of the data types that we have, any of the scalar data types that we have, except text and text image cursor and date time and timestamp. A function cannot return these data types that you can see here. Okay, and then as begin end, just like the stored procedure, the body of the function goes inside this begin and end statements. And finally, remember, your function should return back that return the data type you specified here. Okay, for example, if you are computing the age of a person, then it should return an integer. Okay, so obviously if we have to write a function to compute the age of the person, now obviously to compute the age we require to know the date of birth of a person. So we need to pass in date of birth as the parameter to that function, and it's going to return an integer back, which is nothing but the number of years. Alright, so let's see how to create a user-defined function that computes the age of the person. Okay, now let's get rid of these function calls here. Now if you look at this, I have written this code already just to save some time in typing. If you look at this, I've created a variable called @dob of type date, and there is another variable of type integer age, which is used to hold the age of the person, and I have initialized the date of birth to something 8th October 1982. Now, how do we compute the age of the person? We have already spoken about this in part 27 of this video series. Okay, but let's quickly review it. So I'm using the dateDiff function, and then we are saying, okay, compute the difference in years. Give me the year part, whatever is the difference in years. And then this is my start date, and this is my end date. Compute the difference between them in terms of years. Okay, so that will give us the year part. Now, you might be wondering, okay, look at this. Let's comment this out. This is not required. If this is not there, what's going to happen? Let's try to run this. Look at this. If I run this, I still get the age. Okay, but then there is slightly a problem here. Now, today, the date is September 3rd, 2012. Okay, so if it is September 2012, September 3rd, 2012, now let us say I am born on maybe November 8th, 2011. So if it's November 8th, 2011, this is 2012 September, and if I execute this, I get age as 1 year. I haven't even completed 1 year. Okay, so it just computes the difference in years without consideration to the days and months here. That's why we get that, when I haven't completed actually 1 year, it returns 1 year. So obviously we need this case statement to compute the age correctly. So what we are doing here is basically, okay, from whatever is the difference between the years, we are using this case statement and we are subtracting 1 or 0. Okay, when do we subtract 1 from the difference in years? Whenever the date of birth month is greater than the current system date and time, or if the months are equal, and if the day of the date of birth is greater than the day of get date. Now, the logic is not that important here because we are here to learn about scalar functions. Okay, so if this is confusing, please watch part 27 where we have clearly walked through the logic of how to calculate the age of a person. Alright, so finally, this code will give us the exact age. So if I execute that, it tells me you haven't even completed 1 year. Okay, so that's why it says zeros, which correctly computes that. So this is a bit of transact SQL code that I have. Now, how do I convert this code into a function? Okay, now if you look at this, I want to kind of make this code into a function which takes in date of birth as the input parameter, calculates his age, and returns that back as an integer. So obviously, to create a function, we use the create function statement. So create function, and then the function name. So let's say I want to create, maybe a function like calculate age. Obviously, a function, this function requires date of birth as the input parameter. So let's say @dob, and this has to be date parameter, and it should return back an integer, which is nothing but our age of the person, as begin and finally end. Okay, so if you look at the syntax here, create function, function name, parameters, returns, data type, as, begin, end, and within the begin and end, the function body goes in, and finally you should have a return statement. Okay, so instead of select, you should say you want to return the age back. Whoever calls this function, return the age back to that calling program. Okay, and we don't have to have this initialization here anymore because the end user is going to pass in the date of birth. So you can get rid of that. You don't even require this declaration of the variable here because you have the parameter. So that's our function. So when we execute this, what happens? This function gets created in the sample database. Okay, so if I expand the database, if we go to the sample database, programmability and functions, and this is a scalar function. Why is it called a scalar function? Because it returns a single value. Okay, so that's why it's a scalar function. We will talk about inline and multi-statement table valued functions in the next session. And if I expand scalar functions here, scalar valued functions, and if I refresh this, you should see calculate age function there that we have written. And look at the name, it says dbo.calculate age. That's nothing but DBO stands for database owner, and then dot calculate age is the name of our function, and this function is actually present in sample database. So the fully qualified name of this function is sample.dbo.calculate age. Now remember, to invoke a user defined, a scalar user defined function, you need to specify at least the two part name. Now let's kind of invoke this function. To invoke this function, just like how we have invoked get date and power and square functions, we do it the same way, but we need to use a two-part name. Okay, let's understand that. Let's say my date of birth is maybe October 8, 1982. Now look at this. I'm just saying select calculate age, and when I execute this, it says calculate age is not recognized as a built-in function name. That's because whenever you invoke a scalar user defined function, you need to specify at least the two-part name, database owner dot the name of the function. Here the database owner is DBO. So now when we press F5, we should get the age back. And obviously if you want to give it a column name, you can use a column alias. So when I press F5, I get age 29. Now you can also use the fully qualified name, which is nothing but sample.dbo.calculate age. So even that works. Alright, so we have seen how to create that age function, and then we also have seen how to invoke that function. Now to invoke a scalar user defined function, you must supply at least the two-part name, owner name dot function name, and you can also invoke it using the complete three-part name. Okay, now let's look at how to use this user defined function. We have seen we have used it with the select statement. Not only that, if you remember, we have been working with a table called TBL employees. Okay, so if you look at this, we have this table TBL employees where we have got the ID, name and date of birth of the person. Now I want you to write a query which will give me the name, date of birth and the age of the person. And obviously we have a function, and look at this, in the database we are not storing the age of the person, but we have date of birth. So based on the date of birth, we can actually calculate the age of the person, and we have written a scalar function for that. So what we are going to do here, okay, we want name, date of birth, so name, date of birth, and then the age of the person. To get that, we are using the age function, okay, dbo.age, and to that function we are passing in the date of birth column. So this function is going to calculate age for every person and return that. Okay, so you can use the scalar user defined scalar function in the select clause of a query. Not only in the select clause, you can also use it in the where clause. If you see the second example here, now I want all the people in all the employees whose age is greater than 30. Is that possible? Absolutely. Just like how you use the function in the select clause, you can also use it in the where clause. Look at this. I'm selecting name, date of birth and age from TBL employees, where I'm using the function again, age of date of birth greater than 30, and that returns me the employees whose age is greater than 30. Okay, let's quickly see how to execute these queries. So select, I want the ID, name and dbo dot calculate age, and we have the date of birth column. We want to give an alias as age. When we press F5, we should get the ID, name and age of the person. And similarly, if you want just people people whose age is greater than 30, all you do is you will say, okay, whosever age which is given to us by the calculate age function is greater than 30. So when we execute that, we should only get the two people whose age is greater than 30. So it's also possible to use it in the where clause. Okay, now if you look back, we have also spoken about stored procedures in the past. Now whatever we have achieved using this scalar calculate age function, we can also achieve it using stored procedures. We can write stored procedure which takes in, if you want, you can quickly convert this function. By the way, if you want to look at the text of this function, you can use the sp help text function. We have seen the purpose of this function. We have used it with stored procedures as well. If you want to look at the text of a procedure, you can use sp underscore help text procedure name. Similarly, if you want to look at the text of the function, sp underscore help text and the function name. So now if I look at this, look at this. This is the function implementation. Now instead of saying I want a function, I can say create procedure. I can also convert this to a procedure. Create procedure. Let's call this sp calculate age, and then we will say this procedure is going to take at date of birth date, and we wouldn't say it returns as begin, and finally instead of returning we will just say select age. So when I execute this, what happens? We have the stored procedure created, sp calculate age, and obviously if you want to execute that, we use execute. Again, if you're new to stored procedures, please check our video tutorial on stored procedures that we covered in the past. And if we pass some date of birth to this, it's going to compute the age and select that for us. Okay, so whatever we have achieved using a user defined function, we can also do that with stored procedures. Okay, but the places where you can use a function, okay, you cannot do that with stored procedures. For example, we have just seen that a function can be used in the select and where clause, but can I use a stored procedure in the select and where clause? No, you cannot do that. If you try to do that, you will get an error. So select maybe id from tbl employees table. So what we want the id, name, and if I wanted the age, we have used that function calculate age, to which we have passed the date of birth column. Okay, so if we executed this, we got the age without any problem. But can I do that with stored procedures? Instead of using the function here in the select list, can I use the stored procedure? You cannot. Okay, if you try to do that, you will get an error, because look at this, the way you pass parameters to stored procedure. They are there for a different purpose. Okay, so that's the advantage of scalar functions, and this is one of the differences between a scalar user defined function and a stored procedure. A scalar user defined function can be used in the select and where clause, whereas a stored procedure cannot be. But there are several other important differences between scalar user defined functions and stored procedures, which we will be talking about in a later session. Okay, to alter a function, we use alter function statement, and similarly to delete it, we use the drop function statement. Just like table or stored procedure or any other database object, we use the same statements: alter function function name, drop function function name. On this slide, you can find resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.